So we've just seen the platform engineer using the Ansible automation platform to do some very clever things around automation of infrastructure provision and application deployment. So far in the demo, we've looked at the inner loop. We've looked at the actions of the developer. We've looked at the outer loop in terms of actually taking the code, deploying it, checking it, doing all those things at the actual application level. What we're going to show you now as part of the demo is the use of some additional technology, the Advanced Cluster Manager for Kubernetes and Advanced Cluster Security for Kubernetes, to provide the ops and the administrators the ability to control fleets of OpenShift and Kubernetes platforms, and also to correctly place applications across the estate in a highly efficient and controlled fashion. And now I will pass it over to the ops admin persona to perform that part of the demo, and you might recognize him. So in this segment of the demo, we're going to show you the sysadmin or the ops view of the clusters. And to do that, we're going to use two very cool extensions to the OpenShift Container Platform Plus, both of which are actually installed via supported operators. The first one we're looking at is something called the Advanced Cluster Management for Kubernetes. And what this is basically a super controller application that allows you to control from a single point your entire fleet of OpenShift and Kubernetes platforms. What we're looking at here is basically the front page. It's the overview. And the current fleet that I'm looking at from a perspective of the demo is a bare metal cluster that's currently running the ACM. So that's the controller, a Microsoft cluster, which is running my production estate, and an Amazon AWS cluster, which is running my development estate. What I've done is I've actually intentionally broken my connection to the Amazon one. So you can see I get an instant indication in the cluster status that one of my clusters is offline. Now, the advantage of using ACM is that you get a single point of control, visibility of your clusters. You can actually control and maintain and observe the individual clusters from a single point, but you can also place applications. And that's what I'm going to show you in the first bit of this little demo. So what I've got is effectively three clusters. One of them is actually down. The AWS one is unreachable at the moment, but I've got what's called a cluster set. And a cluster set is basically a grouping of clusters. So I created a cluster set for the Gartner demo, which actually contains two clusters. One is the production one is the development one. And what I can actually do is using the application tab, I can actually create applications that can be placed on appropriate clusters based on rules. And the basis of these applications is the same as Argo CD. So the Argo CD components that we've generated as part of the DevSecOps process, we can now use directly using labeling and controls within ACM to place in multiple distributed clusters. So I'm going to create a very quick one here, and I'm using a basic application because for the sake of time. So I'm going to create an application. I'm going to use an application set for it, and I'll call it Demo App 2. I can choose which Argo server to actually target. In this case, I've got Argo CD installed on the hub where ACM is. So it's using a local instance of the GitOps. I then can choose whether to use a Helm chart or a repo to actually do the deployment of the application. I'm going to use a repository. I'm going to give it my quick demo, which is actually in a directory called app. And I'm going to create it in a namespace, let's say demo app 1. So what this is going to do is going to take the definition of the application from that Git repository, and using Argo CD, it's going to distribute it to that target cluster and keep it compliant to the Git repo. When I hit next, it gives me the synchronization policy. So I can actually specify which components and what nature of the synchronization to do. And this is where it gets to the clever bit. So I'm going to choose the placement of this application. So I'm going to choose my cluster set, which is the Gartner demo one. And what I've done is each of the actual clusters I've got running in that cluster set has a specific additional label I added when I installed it as part of the ACM, which indicates its behavior and what it actually does. So I'm going to add a label expression, and I'm going to choose the label, which I'll create a demo.cluster type. I'm going to match it, and it gives me a list of values that it finds in all of its database. So this has got two clusters. One is labeled with CI/CD, one is labeled with production. And I'm going to deploy it to production. I hit next. It gives me a summary of what I want to do, including the placement information. And then I submit it. So what it's doing now is it's actually building that information that it needs to deploy the application. It's setting up a GitOps application. It's creating something called an application set, which is a superset of applications matched to clusters to deploy it to. I'll give it a tiny bit of time, but if I look at the topology, what you'll see is it's already finished. So the application set has kicked off. It's got a placement, and you can see the placement is based on a label selector, demo.cluster type in production. It's actually targeted a single cluster, which is the AR demo production cluster, and it's created the deployment. It's created the replica set, and it's created the 8 pods that I need for my application. So that application is now being deployed and is centrally controlled by ACM. So this is the advantage you get with using ACM at the end of the process. You've got your DevSecOps for actually doing the development, the actual checking of security, and the operational behavior of it. And then you can use ACM to dynamically place your applications. And you get a good viewpoint on that as well. So ACM is all about basically looking at the clusters. The other application I want to show you very quickly is something called the Advanced Cluster Security. And this is another application that's installed as an operator onto OpenShift. And what it does is it provides effectively a watchman in terms of the security aspects of your clusters. If I pop to the dashboard, this is the first dashboard you see when you go into the Advanced Cluster Security for Kubernetes. And this is actually looking at one cluster. So I've got it actually looking at the development cluster. And it lists the number of policy violations by severity, the images at most risk that it sees, the ages of the images. So it gives you a very good viewpoint for the security people in terms of being able to monitor the security of the system. But it's got some very nice little features I want to show you. And the first one's to do with networking. So what it can do is it can actually interpolate and interrogate the system to build a network map to see what's going on in the system in real time. So what I'm going to do is choose a namespace. For example, if I pick the cool store dev, which is the demo you saw earlier, and what you'll see is a map of the network. And what's nice about this is it will pick up things that are in breach of policy. So for example, if I click on this one here, you'll see it says I've got a missing policy is allowing all network traffic. And that's by default. When you actually create the application, you've got no limitation on the actual ingress other than coming in through the service point. What's nice about using ACS is not only does it give you sort of CV scanning of images, real-time information about the applications you're running, but it can do something like network policy generation. So I can specify the type of network controls I want to do, and it will dynamically create those network policies and apply them to the applications that are running within the cluster. Now, the nice thing about ACS as well is like ACM, it's multi-cluster. So I can actually have all my clusters visible through a single security port, as well as having via ACM, all of my clusters and my applications visible from a single port. So we're making it very easy for the sysops and the administrators to have 100% visibility and observability of the application state and the security state within the cluster. And that is basically the end of this part of the demo talking about the sysops. Thank you. So what we've shown you today is an integrated demonstration using core Red Hat products, in particular OpenShift Platform Plus and Ansible Automation Platform. In addition, we've shown you the new features of the IDP provided by the Red Hat Developer Hub, a fantastic single pane of glass that controls the developer's actions. Every product we've shown you was GA'd 1st of January 2024, but we have some very interesting technology coming in the pipeline. So we're going to finish this demo with a quick overview of the new technology as it's appearing. Thank you for actually watching the demonstration.